Hi, in this video we'll talk about displacements in solution. The first section is going to be about calculating the volume of the solvent based on the displacement volume. Let's take this scenario. We have 200 milliliter solvent being added with 2 grams beads, and as you can see, each 2 gram is displacing the solvent by 10 milliliter. Now, if we don't consider the displacement volume, this will lead to overfilling and, of course, inaccurate concentration. Based on this scenario, as you can see, each 2 gram is displacing the solvent by 10 milliliter. So the displacement volume is 10 milliliters per 2 grams. Therefore, if we want to calculate the accurate volume of the solvent, we need to apply 3 steps. The first step is what's called the theoretical volume or the volume of the container, and that's 240 milliliter. And then the second step is the multiplication of the total mass of the drug by the displacement volume. That's 10 grams multiplied by the 10 ml per 2 grams. And that gives us 50 milliliter. In the third step, we do the subtraction. So that's 240 minus 50, and that gives us 190 milliliter. Therefore, 190 milliliter of solvent is required to be added with 10 grams of the drug to give an accurate volume of 240, a final solution containing 10 grams. This is a visual explanation of what we just explained. Now let's take an example. A bottle contains 5,000 milligrams of amoxicillin powder for reconstitution. Amoxicillin is of displacement volume of 0.8 milliliter per 1.2 grams. You work in pediatric world and you're being asked how much water should be added to prepare a final of 5% bottle. Now, since it's 5% weight per volume bottle and there is nothing mentioned about the final concentration, then the final volume is 100 milliliter. And then the second step is we need to multiply the 5 grams, i.e. the 5,000 milligrams, by the displacement volume. And then this will give us 3.33 milliliter. And the answer is 96.67. But since the question is about the nearest whole number, that will give us 97. Now, a question here is, do we need to convert the milligrams to grams always? No, it's not always. It depends on the mass unit mentioned in the displacement volume. And since in this scenario it's in grams, as you can see, that's why we converted the 5,000 milligrams into grams. The second section is about calculating displacement volume, and it's about simple two steps. The first step is we need to do the subtraction, i.e. the final volume of a solution containing a drug minus the volume without a drug. And this will give us the displaced volume. Then the second step is displaced volume divided by the added mass. Then there will be an extra third step, depend on whether you're asked about an extra thing related to the displacement volume, such as what is the displacement volume per another mass. And we will talk about it later on. This is an example. 200 ml being added for injection to 15 gram of drug X, and this obtains 210 milliliter of solution. What is the displacement volume of the drug? Now we apply the same steps. 210 minus 200, and this gives us 10 milliliter, which is the displaced volume. And 10 milliliter divided by 15 grams, and this gives us 0.66 milliliter per gram. And this is the displacement volume. Now, if the question is about calculating, let's take the same scenario, the same example, but give your answer in milliliter per 500 milligrams. Now we do the same steps, but with an extra third step by multiplying whatever we got by the 500 milligrams, which is 0.5 grams. Why we converted to 0.5 gram? Because the displacement volume is in grams. So we simply add the third step of multiplying the 0.66 milliliter per gram by 0.5, and this will give us 0.3 milliliter per 500 milligrams. That was the end of displacements in solutions. If you have any questions, please don't hesitate to contact us.